Hello and welcome back to the Human Managed YouTube channel. My name is Deborah and today I'll be walking you through the architecture behind our Invicta app. Most security platforms today are point solutions. They connect to a few sources, store data in silos, and give you visibility into only what they can see. But the real problem usually isn't the dashboard. It's what's underneath. You end up with data locked in proprietary formats, inconsistent models across vendors, and no reliable way to reason across the whole environment at once. CyberStory and Invicta were designed differently. The architecture isn't just infrastructure in the background, it's actually the reason why the intelligence is trustworthy. So let me walk through how it works. So with layer 1, we have data collection. CyberStory from Invicta doesn't replace your existing security stack, it reads from it. We ingest telemetry from the tools that you already have, such as endpoint detection, cloud security platforms, identity providers, network appliances, web application firewalls, and other security systems. Each connector writes into a dedicated landing zone, and your data stays isolated in your environment. It never mingles with other customers' data. This layer matters because everything downstream depends on data being complete, consistent, and correctly sourced. Next is the pipeline layer. This is where most of the heavy lifting happens, and ideally users never sit. Raw telemetry lands in object storage first. From there, a structured pipeline runs daily. It normalizes data across different vendor formats, extracts features, applies machine learning models trained against your environment's baseline, and produces stored outputs. Issues get weighted, threats get correlated, and coverage gets measured. So by the time the information reaches the application layer, it's no longer just raw logs. It becomes structured intelligence, scored, aggregated, and organized by security domain. Now, one important design decision here is that the pipeline runs on a scheduled cadence. So posture scores reflect the previous 24 hours, not the last 5 minutes. That's deliberate. CyberStory prioritizes depth and accuracy of analysis over real-time alerting. Your SIEM still handles real-time events, but CyberStory is where you understand what all of it actually means. And importantly, each customer's data lives in a dedicated warehouse with complete isolation for privacy reasons. There's no shared customer database underneath. Access to data requires credentials scoped specifically to that customer environment, resolved dynamically at request time. Next, there's the application layer, what users usually interact with. The stored data services through Invicta.io, the human-managed cybersecurity workbench. The architecture separates responsibilities very cleanly. You have the front end that analysts, managers, and CISOs interact with. Behind that is the API layer. And the API layer enforces authentication and authorization on every single request, not just once at login. Every request gets evaluated. Who is this user? What organization are they part of? Are they authorized to access this specific data? The authorization model is attribute-based, so it's not just simple role checks. It evaluates claims about the user, the resource being requested, and even the subscription state of the organization, all dynamically at request time. If any check fails, the request stops immediately. There's no fail open behavior. That allows the platform to safely support different team structures, including operators acting on behalf of customers, without those boundaries ever blurring. Following, we have the AI layer. This is where CyberStory moves beyond dashboards. There's a conversational AI layer built directly into the platform. Analysts can ask questions in plain language, like what is my security posture today? Which assets require my immediate attention? And the responses are grounded in their actual environment data with their business context. Now, the architecture of this AI layer matters a lot. The AI is not connected to the internet. It is not generating answers from general public knowledge. Instead, it has access to a controlled set of tools that retrieve specific, scoped data from that customer's environment, and only that environment. Every AI tool call goes through the exact same authorization process as every other application request. So the AI cannot access anything that the user themselves wouldn't already be allowed to use. Before any response reaches the user, it also passes through a guardrails layer. Inputs are classified to detect prompt injection attempts. Outputs are scanned before being returned. Anything resembling credentials or sensitive values gets redacted automatically. AI can explain reasoning, but it never exposes raw sensitive data underneath, and responses stream progressively in real time. So users see the AI working through the problem instead of waiting for one large response at the end. One thing worth emphasizing is how intentionally separated the layers are. Connectors write into storage. The pipeline reads from storage and writes scored outputs into the warehouse. The application reads from the warehouse but never writes back onto it. And the AI layer only interacts through application tools. It has no direct warehouse access. Every boundary introduces its own authorization checks. That separation matters because failures stay contained. If the pipeline slows down, the application can still serve cached data. If a connector goes offline, that security domain simply shows incomplete coverage. It doesn't bring down the entire system. The platform degrades gracefully, and importantly, the degradation is visible. It also means that layers evolve independently. New connectors do not require front-end redesigns. New AI capabilities don't require pipeline changes. The architecture is already modular by design. Now to multi-tenancy and isolation. This is usually worth slowing down for because multi-tenant can mean very different things depending on the vendor. In CyberStory, tenant isolation is not enforced purely through application filtering. It's enforced underneath at the infrastructure and credential layer. Each customer has dedicated datasets, and the credentials used to access these datasets are customer-specific, encrypted at rest, and only decrypted in memory at request time. So even if application logic hypothetically fetched the wrong customer information, the underlying storage access would still fail because those credentials simply don't have permission to access another tenant's data. That's defense in depth applied directly to the data layer, not just the API layer. From an operational perspective, CyberStory runs on Kubernetes using a blue-green deployment model. There are always two full environments available. Production traffic points at one environment, while the other receives new versions for validation before promotion. Cutover becomes a routing change rather than a restart. Rollback is equally fast. Configuration and security policy updates automatically trigger pod restarts through a cluster operator watching for changes. So policy never becomes stale. The platform also uses GitOps for deployments, and infrastructure and configuration changes go directly through code review, CI validation, and controlled promotion workflows. There are no manual changes directly in production. And it's important to be transparent about trade-offs. No architecture is perfect. The daily pipeline cadence means posture scoring is current to roughly yesterday, not real time. So if a customer needs minute-by-minute posture updates, CyberStory is not designed to replace real-time alerting systems. It complements them. Similarly, the AI layer is only as strong as the data coverage available to it. If connectors aren't configured for certain domains, posture visibility in those areas will be incomplete. Coverage breadth directly affects intelligence quality. And finally, the system is intentionally designed to fail closed. If authorization cannot be confirmed, access gets denied. That's the correct security trade-off. But operationally, it means misconfiguration surface as access errors rather than silent leakage. That behavior is worth understanding before someone is troubleshooting late. And usually, the most useful technical evaluation starts with the customer's data landscape. What sources are they currently running? What telemetry formats exist today? Which security domains matter most to them? From there, we can walk through what the pipeline would look like for their environment, what connectors already exist, and what the scoring outputs would actually look like before they commit to anything. The architecture is designed to be evaluated, not taken on faith, and we are comfortable with that.